Okay, so let's say we had some ground here, and we had a concave mirror. I'm gonna make it always make your curve very slight when you draw these, because if you make it too big, it makes your pictures all wonky. It doesn't work. Okay. And let's say there was a focal point. This mirror's focal point was here. Of course, you should read the notes to talk about focal point and radius of curvature and the difference between them. It's very straightforward, but you should have read the notes. Okay. Now, let's say we have a robot named. Your robot name.
Henry.
What did you just say?
I said Billaturn.
Billaturn. Okay, I'm going to go with Henry, even though that was a really creative name. Henry seems right for this sweet robot. Okay, who said Henry? Did somebody say Henry? Or did I just imagine that? Okay. Oh, good. Now, imagine that Henry, the sweet robot, is actually enraged by the sight of his own image, okay? Well, okay, I won't say the sight of his own image because he wouldn't see anything at this point. He's enraged by mirrors. And what we're going to do is we're going to remember our phrase, flat to focal, focal to flat. All right, so he's angry, so he's going to take, what? Okay, I don't even want to talk about that. Okay, so he's going to shoot his little laser light, and you want to use a straight edge for these. He's going to shoot his laser right at the mirror. Okay, flat. Now, we talked about, and I showed you this in class, if you shoot it flat at the mirror, which that is not great flat, but whatever, hypothetically, perfectly flat. If you shoot it flat, where will it go next? Through the focal point. Okay, good. So you go flat to focal. This is really hard to balance on my knees, so I'm going to probably screw this up a little bit. Like trying to hold this iPad on my lap and draw is not going well, but whatever. Looks a little sketch, sorry. Okay, flat to focal, one down. Now, he's like, oh, that didn't hit anything. I am angry. I'm a robot. So now, he's going to aim at the focal point. So I'm going to take my straight edge of a paper, whatever. And he's going to point from his hat here to the focal point. So we're going to line our ruler up like that. So between the top and the focal point. And we're going to draw a line all the way down to the mirror. Now, if you go out from the focal point like this and you hit the mirror, what will happen to the laser when it hits it? It will come out flat. So focal to flat. Okay, notice where the laser lines cross. That is where it's going to look. Oh, I didn't draw this well. It's going to look as though the top of the robot's head is. Okay? Few things. Is this a real image or a virtual image? This is real. So in order to see it, we'd have to put a piece of paper there. A screen there, something.
So
Is it, huh?
So if you threw a piece of paper on the ground right now, would you see that image that he just made?
If you put a paper like it wouldn't necessarily be on the ground, it'd be like almost like under his ground on a screen. Yes. Yes. Yeah, you would see his image. Okay? Now, so he's real. Is he upright or is he inverted? Inverted. In other words, if you don't know that fancy word for upside down. Okay? He's inverted. It's a little hard to tell because I didn't draw my picture particularly well, but is he bigger or is he smaller? He's smaller. They're usually a little more obvious. And that is pretty much it for ray diagrams in that position. Okay? Now they're going to get a little bit more complicated, but not much. That's basically what you do. Okay? In fact, if you do this to scale, where you measure, okay, let's say I had a 2 centimeter thing here, and you draw it with the correct angles, you can actually physically measure on a ray diagram, and you can do that tonight, and you can find the exact height and position of this guy. Like, you could do this and it'll come out pretty much perfect. All right, let's try another one, a little bit more complicated. How much? Let's say we had our concave mirror. Again, make it very slightly concave. If you make it like extremely concave, it's kind of hard to see this stuff sometimes. And we have our ground. Now we're going to have our focal point here. And we're just going to move our robot inside of our focal point. Okay? He's inside the focal point. He still hates mirrors. So he's going to take his little laser light on his head and he's going to shine it straight at the mirror very angrily because he'd like to destroy mirrors. My phone is ringing. Come on. Oh, okay, sorry. We just did focal to flat to focal. Sorry, video. So to somebody who's over here, it's going to look as though the laser light came inside the mirror. So you're going to continue into the mirror like that. All right, now let's do our other one, focal to flat. This is a little bit tricky. What you're going to do is you're going to line up from your focal point and the top of your object. Lay it down. And imagine that the robot was to shoot straight out, almost as though the light was coming from the focal point. Shoo. Okay, so you line up between the top of the object and the focal point, and you're going to go straight up until you hit the mirror. Okay, where you hit the mirror, you're now going focal to flat. So you're going to come out flat like this. Notice, sorry, I got to move this a little bit. Notice that the light on this side of the mirror never met. So are you going to have any possibility of a real image there? No. So you keep your thing flat, they keep your ruler flat there, and extend that into the mirror. Okay? Notice where the virtual light crosses. Okay? That is where you are going to get your image. So you're going to now look like you have a robot in here. Okay, so is the robot going to be real or virtual? He's going to be virtual. Is he going to be upright or inverted? Upright, good. Okay, and is he going to be bigger or smaller? Bigger, okay, larger. Good. Okay, this is kind of fun. Now, I don't have enough of these mirrors, so. All right, so diverging or convex mirrors, they bubble outward. So this is weird. Okay, these guys, if you shine light at them, which way, if I shine a flat light, which way do you think the light's going to go? Up or down? Up, right? It's going to go boo. And if I shine it here, boo, like that. Okay? So it almost, let's go back, sorry. It almost looks as though like the laser light was coming from inside the mirror, right? I'm going a little fast here. So now let's do the same thing with a bubbling out mirror. Flat. Where would the focal point be, do you think? Inside or outside? Inside the mirror. Very good. Okay. So we have a kind of a focal point here. All right. So we're going to have our robot stand in front. Henry. Okay. All right. Henry still hates mirrors. So he's going to shoot straight at the mirror. And you're going to lay your thing down so it goes straight to the mirror. Huh? No, you're good. Okay. Flat. And now you're going to lay between the place where it hits the mirror and the focal point. So focal, okay? Outside, do a solid line, because that's the way the light would actually travel. Inside, do a dotted line, because that's where it looks like the light came from. All right, so that was flat to focal. And now we're going to do focal to flat. So top and the focal point, lay a ruler down connecting those two. Okay. We're going to aim at the focal point. So we're going to shoot our laser down toward the focal point. And when it hits the mirror, what is it going to do? It's going to come out focal to flat. Very good. It's going to go flat. But it's going to look as though that light came from inside of the mirror. So Henry is going to be, is he going to be real or is he going to be virtual? He's going to be virtual. Is he going to be upright or inverted? Upright. Is he going to be bigger or smaller? Smaller. Take a look at your ray diagram. Is there any position you could put the robot in where that would not happen? People are shaking their head. No. You can't, no matter what, the diverging convex bubbly out mirror will make an image that is upright and smaller. Take a look at the other mirror. No matter what you do, no matter how close you get, the one that bubbles out towards you, the diverging convex mirror, is going to look as though you are always smaller, upright, and inside of the mirror. Try it now. This looks